Hello everyone. In this video we're going to go over the Chapter 3 practice test. Alright, so our very first question is asking about Henry, who is 3 years old and he weighs 30 pounds. And we're going to compare him to other 3-year-old boys who have an average weight of 31.5 pounds with a standard deviation of 2.1. We want to know Henry's z-score. So Henry, our z-score is equal to the score, x, minus the mean, divided by the standard deviation. So Henry has a weight of 30, and we can subtract that from 31.5, the population mean, and divide by the standard deviation. Right? So noting here that our numerator is 30 minus 31.5, which is negative. We're going to have a negative z, and we're going to have a negative z because Henry's below the mean. If we compute that, we find a negative 0.71. Right? So that is our Henry's z-score is negative 0.71, indicating that he is 0.71 standard deviations below the mean. Question 2 asks what percent of 3-year-old boys is Henry heavier than? So we're going to draw a normal distribution and locate on that normal distribution with a mean of 0, which z-scores always have a mean of 0. And Henry has a score of negative 0.71. So we want to know what percent of people, or 3-year-old boys, Henry is heavier than. And he is heavier than everybody off to the left here. Okay. So we're going to use our z-table to find the body and tail of 0.71. Okay. So we're interested here in the tail, the smaller part of the distribution. So I'm going to use a p-value calculator rather than a table, and I've already entered here a z-score of 0.71. I don't have to enter it as negative because the z distribution is normally distributed and symmetrical, so positive and negative doesn't matter. What matters is if we're looking at the body or the tail. So the tail that I am looking at here is this proportion here, and we have 0.2389. or 23.89%, right? Henry is heavier than 23.89% of 3-year-olds. Okay, for question number 3, we have the average weight of 3-year-old boys is 31.5 with a standard deviation of 2.1, and Garrison weighs 34 pounds, and we want to know Garrison's z-score for his weight. Alright, so for Garrison, I know that I'm working with a z, and I have a score minus the mean divided by the standard deviation. His score is his weight, which is 34, and we're comparing that to a population mean of 31.5 and dividing it by 2. So you can tell our numerator is positive now. We're going to have a positive z-score because Garrison's above the mean. And I get a z of 1.25. So, next, we're going to figure out the percent of 3-year-old boys Garrison is heavier than. So to do this, I'm going to draw a normal distribution and locate Garrison on this normal distribution. A distribution has a mean of 0 and a standard deviation of 1. And Garrison has a score of 1.25. That is his z. So we want to know what percent of 3-year-olds Garrison is heavier than, and he's heavier than everybody off to the left here, right? And so we need to find, if we're looking at the distribution, we're going to look this up in the z-table or a z-calculator. To the right here is the tail, but what we're interested in is the body. That's more than 50% of the distribution we have shaded in. So we're going to look up the body. So I'm going back to our z-score calculator, entered a z of 1.25. And you can see that our body here is 0.8943, 0.8943, or Garrison is taller than 89.43% of 3-year-olds. Okay. Question 5 is asking us to compare 2 different test scores. We have one student who took a Spanish fluency test, and the other took a German fluency test. And we want to know who did better on their respective standardized tests. So these 2 tests have different means and standard deviations, so we're going to convert each student's score into a z-score. We're going to start with student A and convert their score on the Spanish fluency test to a z-score. Okay. So the person, we're looking at their score, minus the mean and divide by the standard deviation. So their score was 62. The mean on the test was 50, and we're going to divide by 10, right? So we have 12 over 10, which gives us 1.2 as the z-score for student A, right? So student A is above the mean by 1.2 standard deviations. Okay, so now we can look at student B. So student B, we're going to compute student B's z-score, where the z is the score minus the mean divided by the standard deviation. And their score on the test was 120 with a mean of 115. I'm going to divide by the standard deviation that was equal to 20. So this person's also above the mean. They're above the mean by 5 with a standard deviation of 20, which gives us 0.25 for student B as their z-score. Okay. Now if I want to know who did better, I can just look at their z-scores. Student A did better than student B. If I graph this on a normal distribution with a mean of 0 and a standard deviation of 1, you can see that student A would be right about here at 1.25, so they did better than everybody to the left there. Student B has a z-score of 0.25. They only did better than everybody to the left of them. Right? So student A has a higher z-score and did better than student B on those. All right, the next questions have to do with proportions of z-scores, and that's going to be using the calculator or a z-table. Okay, so in this example, we're looking at a z of 0.7. So I draw a normal distribution with a mean of 0 and a standard deviation of 1, and I locate 0.7, and I want to know what proportion of z-scores are higher than 0.7. So I'd be looking at everything higher than 0.7, and so in this case I would be looking for the tail of the distribution. So if I go to my p-value calculator and enter 0.7 for the z, I'd look at the tail. And so for my tail, I get 0.24196, or 24.196% of the scores would be higher than a z of 0.7. The next question asks, what proportion of z-scores are lower than 0.7? So now we go back to the p-value calculator, and here we're interested in everything lower than 0.7, so this would be the body. Right? This would be the body that we're looking at, and in this case the body is 0.7580. And note that the body and tail together add up to 1, or 100% of the scores are under that distribution there. Okay. Our next question asks, which of the following z-scores represents a raw score that is farthest away from the mean? So when you're looking at how far things are from the mean, you can start by drawing a normal distribution. And the mean is 0 for z-scores with a standard deviation of 1. So the further things are away from 0, either on the positive or negative side, is how far they are from the mean, right? So if you have 1.9 would be right here, negative 2.4 would be over here, right? And what else we have? 0.20 would be here, and negative 0.70 would be around here, right? So our negative 2.4 would be the score that is the farthest away from the mean. Next, question 11, a z-score of 1.0 means that. So z-scores are interpreted in raw or in standard deviation units. So a positive z-score means that somebody is above the mean, right? And they're above the mean by 1 standard deviation. Okay. So we don't know anything about raw scores. What we can talk about is how far people are above the mean. So this raw score is 1 standard deviation above the mean. We don't know about typical distances between raw scores or between the z-scores or anything like that. All it's telling us is the distance an individual raw score is from the mean in standard deviation units. Okay, next, question 12. An IQ test is a mean of 100 and a standard deviation of 15. If you convert all of the scores in the distribution into z-scores, that distribution will have a mean of 0 and a standard deviation of 1. And that's always true for z distributions, right? Whenever we draw them, we're always drawing them out so that they have a mean of 0, right? We draw this distribution. Our mean is 0, and our standard deviation is 1. And that is always true, no matter what your original mean and standard deviation are. That's the reason we're computing into z-scores, is so that they are on a common scale. Okay. Next, the z-table can only be used to find probabilities if the distribution of scores is normally distributed. That is true. It's called the unit normal table, and it only works for normal distributions. The same thing is true for that calculator that we have to use to find bodies and tails. You can only use it with normal distributions. Okay, next we're looking at using the z-score formula kind of backwards. We're going to find someone's raw score. Okay, so we're going to look for somebody's raw score here, and we know that their z is equal to the score minus the mean divided by the standard deviation. We know that their z-score is 1.5. We do not know their raw score, but we do know that the mean is 100 and the standard deviation is 15. Right? So to solve this, you take 1.5 times 15. Right? You're multiplying both sides by 15, which gives you x minus 100. And then you're going to add 100 to both sides. Right? So you'll have 1.5 times 15 plus 100, which will give you your x. And that, if you work it out, will give you 122.5. That is the person's raw score. Okay? And we could tell that they were going to be above the mean, right? They're above the mean by 1.5 standard deviations there. All right. Next, a similar one where we're going to solve for the raw score, but now we have a negative value to work with. So our z is equal to the score minus the mean divided by the standard deviation. Our z-score is negative 0.8. We don't know the actual raw score. The mean is 100, and the standard deviation is 15. So now you take 15 times negative 0.8 will give you your x minus 100. Then you add 100 to both sides. So I have 100 plus 15 times negative 0.8, which will give you your x. So if you compute that, you'll find that your x is equal to 88. Okay. That person's below the mean by 0.8 standard deviations. All right, next, question 16 is finding a z-score that represents the bottom 15% of a distribution of scores. So this one's a little bit tricky in that you're going to be using the z-table backwards. So what we have is a distribution of z-scores. It's a normal distribution. I want to find the bottom 15% and separate it out from the top 85%. So what we're going to do is use the unit normal table to find a body of 0.85 with a tail of 0.15. Okay? You can't use the calculator to do this. You're going to need to use a z-table. And so if I look at a z-table, I'm looking for 0.15 in the tail and 0.85 in the body. Okay? So you can see we're very, very close to that here at a z of 1.04. Right? So I look up, I get a z of 1.04, but now I have to look at my graph and see that clearly this is a negative z. Right? Z's have a mean of 0. This is on the negative side, so it would be a z of negative 1.04 there. Okay. All right, so I think that is all we have for this chapter here. So I hope that helps.